All right, here we go. Number 15. Let's take a look, see what you came up with. Walk us through. Nice and out.
Added 25 minus 3 gives you 22.
Okay.
Then I multiply by 2. Then I added 4. Then divided by 6. 58.
All right, so the final answer was
B.
B. That is correct. All right, so basically we're just doing everything backwards. We started with step 3 and work our way back up to step number 1. All right, got any volunteers for number 16? Everybody's going to come up here, guys. So if you find one that's easy, might as well grab it. All right, 16, come on up. Number 16. Jill's Favorite Store is having a one-day sale offering 20% off the merchandise. Jill spent $99.20 on the day, excluding the tax. What would the purchase cost be at full price? All right, let's see, what'd you come up with? All right, and how'd you get H?
I multiplied everything by 0.2 and subtracted the original amount by 10%.
All right, show us how you did that with H then.
H,
So you did what again? Show it.
124 times 0.2.
Which is 20% as a decimal, right? So what'd you get when you multiplied that?
Yeah, what is it?
Help them out, guys. What is that? 124 times 0.2.
25.8. 25.8.
Okay, write it down. And what do we do with that 25.8? 124. And that equals a total of 99.20, which is exactly what it says right there. Okay? Very good. Not exactly the way I did it, but that doesn't make his way wrong. Okay? 24.8, not 25, right? So this was 24.8.
I said 24.
But it should still come out to $99.20. All right, number 17. On to 17 here. All right. Gotta be quick. 17. All right, on this one, Thomas paid $598,060 for a house to be constructed. He paid $55,000 for the lots and $210 per square foot. We're looking for how many square feet were in this new house. All right, so what'd you do?
I took the original price, $598,060,
All righty, that's the original price.
and subtracted 55,000,
Yep.
and that equals
Okay, so that equals 543,060. I think that's what that is.
yeah,
And what are we going to do with that?
divided by 210.
Okay, very good. We're going to divide it by 210, which is how much they're charging per square foot. And it turns out that is what?
200. So
Very good. D was the correct answer. 2,586. All right, how about number 18? Here's another easy one. All right, go for it. Number 18. On number 18, remember, it does say you have a method of your choice. You can use any method you want to solve that part, right? So go ahead and move on to the little arrow at the bottom. So what method do you use? Factoring. Factoring, all right. All right, so he's factoring x squared plus x minus 2. And those factors turn out to be x plus 2 and x minus 1, which means the solutions are the opposite of that, which is x minus 2, x negative 2, and positive 1. So F was the right answer. That is correct. Don't forget, we could also use graphing method. We could also use quadratic formula. those would also give us the same exact answer. It doesn't have to be that method. All right, moving on to 19. Next, there's another easy one. That should be fairly easy. 19, which quadratic equation has the roots 4 and negative 8? Which of those choices has the roots 4 and negative 8? Very good. It's just the opposite of what we just got through doing. If we know the roots, then we should also know the factors. They're opposites of each other. From here, we do a little FOIL method. Yep, looking good. Plus 4x minus 32. Very good. And that is correct. D is the correct answer. That is the one that has the roots 4 and negative 8. All right, moving on. Number 20. Number 20. On number 20, we're looking for the discriminant, and I left that little formula up on the board just in case you need it. B squared minus 4AC is how we find the discriminant. Very good. Notice we do have to have the equation equal to 0 first before we find the discriminants. All right, so now let's go ahead and find that discriminant. And to find the discriminant, we're using the b squared minus 4ac. So all she's doing is plugging in the numbers. Okay, so negative 8 squared is 64. Negative 4 times 7 times 1 is 28. And 64 minus 28 is 36. And that should be a 36, not a 39. And that is 2 rational roots because 36 is a perfect square. You can take the square root without getting a decimal. All right, number 21. Hurry. 21. 21. Greg is looking at a graph of a problem. Its vertex is negative 1.25 and negative 1.125. It intersects the x-axis at 2 and negative 0.5. It intersects the y-axis at 2. We're looking for the roots to this equation. So what did you find for the roots? All right, roots are the same thing as what? The solutions or the x-intercept, which is what it has up there. The x-intercept for 2 and negative, or not negative, but 0.5. All right, 22. 22. Nobody's brave enough to do 22. All right, we'll come back to 22. Let's go to 23. 23. Oh, come on, that's freebie there. 23. Benji. We're all going to come up here. There's an easy one. Number 23. Again, we'll come back to 22 here in a second. Number 23, if a system of linear equations has only one solution, what would the graph look like? That is correct. The line would be intersection. What is coinciding lines? When they're on top of each other. What kind of solutions do you have when they're on top of each other? All real numbers or the infinite number of solutions. What about parallel lines? No solutions. What about perpendicular lines? That would be the same thing as intersecting lines, right? One solution. 24. It technically could be, right? Because they are intersecting, that would still have one solution.
I just used matrix and I put this.
All right, show me what your system is, and then there's nothing wrong with using the matrix. All right, so there's one equation, A plus S equals 300, which is the number of tickets. They charge $9 for the adult tickets. They charge $4 for the student tickets. And the total amount of money they collected was $2,075. And you said you use what method again? Matrix. Now, which one do you use when you use the matrix in that math? When you look up, when you're finding the solution here in matrix.
Is it the R?
R, there you go. RREF. Make sure it has 2 R's. All right, number 25. Number 25. Who hasn't gone? Andy? 25. We got another system here, very similar to number 24. This one was already set up. Alright, looks like he's going to use some elimination method. So he's going to take the first equation and multiply it by a 2. Very good. Second equation is going to stay like it is. And are you adding them or are you subtracting? You're adding. Alright, so we're adding the two equations together, which is giving them a negative 8x equals to a negative 32. Divided by negative 8. And we end up with x being equal to a positive 4. And if we want to find the y value, we're going to take that 4, substitute it back in for x. Remember, it doesn't matter which of the equations you use. You can use any of the equations you'd like. Alright, we end up with y equals to a negative 2, which means the right answer was which one, Ann? D. Alright, that was the elimination method. Remember, we could also use the matrices. We could also use substitution or graphing. Okay, let's go back to that number 22, I think it was. 22. What was the answer then? F. F is the correct answer. Now, how did you get that? Yes. Alright. Now, we saw this on one of the tests here. We know that 3 of the sides is going to make up this rectangular pin. We have no idea what this is, so we're going to call both of these sides x's. We know that the remaining bits is going to come over here, so we're going to do 600 minus the 2 x's that we have on each side. Just making sure you're paying attention. There it is. 600 minus 2x. Remember here, to find the area of a rectangle, we're multiplying the length times the width. So we're multiplying x times the 600 minus 2x. And if we do a little distributive property here, we get 600x minus 2x squared. And what that's going to equal is y, which is going to represent our area. That's what the y is. It represents the area. This is a quadratic. Now let me go ahead and rewrite it so that it looks a little more familiar to us. Put it in standard form here. Okay. Same thing. Now that quadratic, we're trying to maximize the area. We want to know what is the most amount of area we can get here. So we're going to solve that quadratic. So what we're going to do is, anybody know what we're going to do? Actually, we're looking for the vertex, right? Because we're looking for the maximum. That's what we're looking for. So this is the little formula that Andy was asking about earlier. I think it's what was that? Negative b divided by 2a. That's going to give us the x value for that maximum. So our b in this case is a 600. Our a is a negative 2. So if I do negative 600 divided by negative 4, I end up with, what is that, 150, something like that? Check that, 150. So x is going to represent 150, which means that this side over here is 150. And if that's 150, I put 150 here. 600 minus 2 times 150 ends up being a 300. So this piece right here is 150. This piece over here is 300. And if I multiply those two numbers together, guess what I get? We get that 45,000, you guys. That's the maximum area we can get if we use the dimensions of 150 and 300. All right, so that takes care of our review.
So we all finish early. Can we have like a party here?